relative humidity passes through passes through a passes through a passes through a furnace passes through a furnace and then and then and then through a humidifier humidifier in such a way that 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 the final drivable temperature, the final drivable temperature is 30 degrees centigrade and relative humidity 50% relative humidity 50% relative humidity. So relative humidity 50% relative humidity. 50% relative humidity. Find the heat. Find the heat and moisture and heat and moisture added to the air also determine the sensible heat factor. The sensible heat factor of the process. So this is a problem which comes under heating and humidification. So atmospheric air at drivable temperature of 16 degrees centigrade and 25% relative humidity passes through a furnace and then through a humidifier in such a way that the final drivable temperature is 30 degrees centigrade and 50% relative humidity. Find the heat and moisture added to the air. Also determine the sensible heat factor of the process. So here, if you see the problem, write the given data. And so here the given data is so drivable temperature is given at inlet conditions. PD1 is equal to 16 degrees centigrade. Next one is phi1 is given relative humidity. Phi1 is equal to 25%. Next one is final conditions are given. Drivable temperature is given. PD2 is equal to 30 degrees centigrade. Next one is phi2 is given as 50% relative humidity. So it asks you to find. So what is Q? Amount of heat added. Just one, what is amount of heat added. Next one is what is the moisture content added, that is omega 2 minus omega 1. Third one is sensible heat factor. Just find all these values. So let us go to the psychrometric chart. Let us go to the psychrometric. First locate the points inlet conditions of atmospheric air, that is 1, and later on locate the point in the psychrometric chart. So let us import the psychrometric chart. So So if you import the psychrometric chart, I am inserting the psychrometric chart so that understand. Insert psychrometric chart. Yeah. Let us take the psychrometric chart. This is a psychrometric chart. Let us look at the point 1 in the psychrometric chart. So point 1 is PD1 is 16 and pi 1 is 25. We go to the 16 degrees centigrade. We go to the 16 degrees centigrade here. Go to the 16 degrees centigrade here. So this will be the 16 degrees centigrade. So from here, we draw one vertical line. This will be the 2D1. 2D1 is 16 degrees centigrade. 2D1 is 16 degrees centigrade. Next one is this will be the 25. This will be the 25. So look at this one as a point 1. Let's look at it as a point 1. Next one is go to the TD2, that is 30 degrees centigrade. Go to the 30 degrees centigrade. Go to 30 degrees centigrade. Next, from there you draw one vertical line. From here you draw one vertical line. So from here you draw one vertical line. From 30 degrees centigrade, draw vertical line. So this will be 50. This will be 50 relative humidity. This will be the second point. So now you join 1 with 2. So now you join 1 with 2. So 1 to 2 represents heating as well as dehumidification process. So from 1 you draw one horizontal line and represent it as a. 1A is called as sensible heating process. So A to 2 is called as uh, latent heat, that is humidification process. Humidification process. So now from psychrometric chart, to try to find H1 value, try to find H1 value, try to find H1 value. So from 1 you draw constant enthalpy line, you get H1 value. This is H1 value. This is H1 value. Next one is you go to the second A point. From A, you draw one line. So that will be HA value. That will be HA value. So from A, you draw one enthalpy line. That will be HA value. This is HA value. So this is HA value. Next, you go to the second point. From second point, you draw one constant enthalpy line. So that will be H2 value. That will be H2 value. So like this, we are finding the H1, HA. This is H2. Next one is from one, you draw one horizontal line. From 1, you draw one horizontal line. This will be omega 1. So from 2, you draw one horizontal line. This will be omega 2. This will be omega 2. So from measurements. So now from measurements from the psychrometric chart, from psychrometric chart, from psychrometric chart, from psychrometric chart. So from psychrometric chart, we have so from our psychrometric chart we have, so H1 is equal to and HA is equal to, next one H2 is equal. So you go to the psychrometric chart here, H1 value will be around 23. So here the value will be around 23. So H1 is here 23 kilojoules per Kg of dry air. Kg of dry air. Next one is you go to the HA. So from HA, that is equal to 38, 38, 38 kilojoules per kg of dry air. Kilojoules per kg of dry air. Next one is put H2. So from the graph itself, you will get H2 is equal to around 64. So the value of H2 will be 64 kilojoules per kg of dry air. Kilojoules per kg of dry air. Similarly, you will get omega 1, that is specific humidity point 1 is the value is that is around 2, it is there around 2. So 2 grams it is. If it is in kgs means 0.002. So from that you will get 0.0026 kilojoules per kg of dry air. Kg of dry air. So you will get like this. Similarly, specific humidity at zero point 0.2 is equal to, go to the graph. So it will be around 15. This is 10. So the value will be around 13. So 13 grams it is, divided by 1000 means the value will be coming around 0.0132 kilojoules per kg of dry air. So these are the values we got from the psychrometric chart. So once we know the values, then we'll go to the calculations. Case one is amount of heat added during the process. Amount of heat added. Amount of heat added during the process. Amount of heat added during the process. So the amount of heat added during the process is Q is equal to final enthalpy minus initial enthalpy. So final enthalpy will be H2 and initial enthalpy H1. So that is equal to Q is equal to H2 value is 38. H2 is 64 kilojoules. 64 kilojoules per kg of dry air, and H1 is 23. H1 is 23. Therefore, you will get Q is equal to 41 kilojoules per kg of dry air. Kilojoules per kg of dry air. So like this, we are finding the amount of heat added during the heating and dehumidification process. Next one is second case will be case two is this case two. The case two is amount of moisture content. Amount of moisture amount of moisture added to the air. Added to added added to air during the process. So that is given as omega 2 minus specific humidity at 0.1 minus specific humidity 0.2 minus 0.1. So the value will be 0.0132 minus at 0.1 the value is 0.0026. So therefore, the amount of specific the moisture added will be W2, omega 2 minus omega 1. The value will be coming around 0.0106 kilojoules per kg of dry air. So last case is case 3. In case 3, we are finding sensible heat factor. Case 3 is sensible heat factor. Sensible heat factor. Case 3 is sensible heat factor. So it is given by sensible heat factor is equal to formula is for sensible heat factor will be SHF is equal to sensible heat plus divided by sensible heat plus latent heat. Or we can write in terms of enthalpies, that is HA minus H1 by that is H2 minus total heat will be added to H2 minus H1. So enthalpies we know at all points from the psychrometric chart. Therefore, 38 minus 23 and 0.3 is 64 minus 22. So the modified calculation, based on the modifications, you will get SFH, SHF is equal to sensible heat factor is equal to sensible heat factor is equal to 0.366. So like this, we are solving the problem on cyclometric process, which is heating and humidification. Thank you.